This is a video on combustion for the Year 9 science course for the topic Chemical World. Combustion is a very familiar chemical reaction. It's found all around us every single day. It helps generate electricity. It's responsible for allowing for transportation. It helps us cook our food, keeping us warm, even allowing us to live our lives through respiration and so on and so forth. It's very important. So combustion is another way of saying burning something in the presence of oxygen. Okay, it's another way of saying that. It's also known as an oxidation reaction. This is scientific lingo, chemistry lingo. Okay, ox to do with oxygen. Okay, so it's a reaction which involves oxygen. That's what oxidation reaction means. Combustion comes in various forms. It comes through corrosion involving the formation of things like rust and the burning of fuels and other materials, as we'll see. So there's two main different categories of combustion. You've got combustion of metals. That's number one. When you burn a metal, you get a metal oxide. That's the general form equation for combustion of a metal. So any metal could be, for example, let's take magnesium. If you burn magnesium, get a lighter and start burning it. I don't recommend you do this because the light is so intense from the reaction that it can potentially blind you in the long run if you look at it for too long, so don't do it. You get magnesium oxide. And all I've done here is really just replace the word metal with magnesium. Okay, let's do another one. Let's say sodium plus oxygen. You get sodium oxide. Okay, and so on and so forth. So you just replace the word metal with the element that you're looking at. Okay, combustion of metals, it's just metal plus oxygen makes metal oxide. And you get heat and light released as well. Okay, plus heat and light energy. We don't do this anymore at our school with magnesium, burning magnesium. Particularly dangerous, especially in the hands of students. But you can watch videos online. It's a pretty intense reaction. You get a lot of light, and if you stir at it for too long, you can go blind temporarily. So I wouldn't recommend doing that. So that's combustion of metals. Number two, there's the second type of combustion reaction, combustion of hydrocarbons. Hydrocarbons, these are compounds made of hydrogen. They're made of only hydrogen and carbon, H and C. Hydro for hydrogen and carbon for carbon. So fuels, fossil fuels, they're hydrocarbons. Fossil fuels, so petrol, gas, and oil. And whenever you burn a hydrocarbon, you get the following chemical equation. So hydrocarbon plus oxygen, carbon dioxide, and water. You always get carbon dioxide and water. E.g., let's take methane. Methane is used in natural gas. If you have a gas stove, you've got methane. The way it works, a gas stove is you've got a lighter on the stove. So when you turn that knob, you're basically lighting a spark, and you've got gas coming out. The gas ignites, and there you have it. Carbon dioxide plus water. This is the same for things like butane, another type of fuel, butane, propane. So any fossil fuel you take, any hydrocarbon, you burn it, you get carbon dioxide and water. Okay, and the issue with fossil fuels, with hydrocarbons, is that they pollute the atmosphere. That's due to carbon dioxide being released. So carbon dioxide is not particularly good for the atmosphere, too much of it. That's for another topic. And then this leads me into the main categories of combustion. So these are combustion of different materials. There's different types of combustion in terms of the amount of oxygen they produce, or they use, I should say. There's complete and there's incomplete combustion. Let's compare the pair. So complete combustion has plentiful oxygen. So there's a lot of oxygen involved. Incomplete has insufficient oxygen. Okay, just think of the word complete. Complete means finished or fulfilled. So plentiful oxygen for complete combustion and insufficient oxygen for incomplete. Complete produces carbon dioxide, CO2, and water, H2O. Incomplete, however, produces either carbon monoxide, which is CO, carbon monoxide. It's carbon monoxide because there's one oxygen. The prefix mono means one. There's one oxygen here. On the other hand, because it's carbon dioxide here, the di means there's two oxygen. That's what the prefix 2 means, di, right? Either carbon monoxide and water, or carbon on its own, also known as soot. It's like a black powder, and water. So two potential scenarios for incomplete combustion. Now with incomplete combustion, it's dangerous, a lot more dangerous, because the carbon monoxide produced is toxic, and also soot as well. It's not very particularly useful. Carbon, so with cars in particular, particularly the old cars, antique cars, they tend to have incomplete combustion going on, especially with their exhausts. A lot of them you'll notice with black smoke coming out. That's carbon monoxide mixed with that's carbon basically coming out, soot. That can pollute the air. That can make cities dirty in terms of their buildings. It can get into people's lungs. Carbon monoxide is actually colorless and odorless and very toxic. That's why they say don't have a barbecue indoors, especially with the windows and doors closed, because there's been cases where families have actually died as a result of that, because barbecues release carbon monoxide gas. You can't see it, you can't smell it. And carbon monoxide also prevents blood from carrying oxygen. Okay, if you inhale too much of it, you could potentially die. In terms of my aviation background, in the cockpit, so particularly for small aircraft, they will tend to have carbon monoxide detectors. In fact, by aviation law, you're supposed to. It's like a sheet, and you've got like a dot here, colored dot. And when that colored dot, typically orange, turns black, that means there's carbon monoxide. So that's a way of detecting it. Now, when you see that in the aircraft, you've got to hop out straight away. Or that's if you're on the ground, or if you're in the air, you've got to come back down and land. Because sometimes there's a fuel leak from the engines, and that results in carbon monoxide emissions. But it's very toxic, not pleasant. Carbon dioxide produced in complete combustion is less dangerous. Let's look at some example reactions. So for complete combustion, let's compare the following reactions. So let's suppose I've got propane. Propane's a hydrocarbon plus oxygen. I'll get carbon dioxide and water. Let's look at two scenarios. Okay, so suppose I have the following scenario for combustion, and I'll write now the following chemical equation. So for propane has the chemical formula C3H8 plus oxygen. Let's suppose I've got 5 oxygen molecules, and I'll get this. So I'm writing the balanced formula. This, and I've got this. I've got the same propane, but written like this. Now, comparing the pair, you can see, suppose they ask you this in an exam, which of the following corresponds to complete combustion? You would look at each, and you would see that you would compare the pair. The 5O2 means there's 10 oxygen molecules. the 3.5 O2 means there's 3.5 times 2 oxygen, 3.5 times 2 oxygen molecules, which is 7. So clearly the first one has more oxygen, and the first one also produces carbon dioxide, as opposed to the second, which produces carbon monoxide. So the first one corresponds to complete combustion, and the second one, incomplete combustion. And I'm sure you've seen this already, particularly in junior science with the Bunsen burner flame. Here's a Bunsen. So if you close the air hole for the Bunsen, what you're doing is you're preventing oxygen from reaching the barrel, reaching the Bunsen. So closed air hole results in a yellow flame. When you get a yellow flame, that's incomplete combustion because there's insufficient oxygen. If you put like a test tube beneath the flame, make it a bit smaller, on top of the flame, you will notice eventually over time a black sort of substance builds up at the bottom. That's carbon, that's soot. With an open air hole, however, you'll see a blue flame. That's called the heat flame, and that's a result of complete combustion because there's plentiful supply of oxygen. Air hole is open, you're letting in more oxygen. And so that's combustion in a nutshell.